Hi, my name is Ka Kit.
Hello, my name is Gimantha.
And today we'll be conducting an experiment with surface tension and surfactant with two different objects.
For the first part of the experiment, we'll be using food dye, and for the second part of the experiment, we'll be using a paper clip.
Okay, so we will also be explaining the physics behind it, and then we will be going into how it links to life science. Before we begin our experiment, we need to make sure we do not get injured in the process, even though the equipment used in the experiment poses little to no harm at all. Therefore, we will be needing gloves, safety glasses, and a lab coat.
For the first part of the experiment, we'll be needing food dye, a pipette, Q-tips, cold water, dish soap or detergent, a small container to hold the detergent, and a flat container to hold the water. First, we will pour some cold water onto the flat container. Then pipette a drop of food dye into the center of the water. The number of food dye used is optional. For our experiment, we'll be using 5 different colors of food dye. As you can see, when the Q-tip is dipped in the water, there is no reaction taking place. When the other end of the Q-tip is dipped in the detergent and then dipped back into the water, the dye disperses from the middle towards the edge of the container. Here is a closer look at what happens when a surfactant is dipped into the water with one end of a Q-tip.
For the second part of this experiment, we will be needing 2 different paper clips, one of which will be bent carefully as shown in the video. Also, we will be needing some cold water, a small container, a Q-tip, some detergent, and a larger container. Gently place the paper clip on the surface of the water with the bent clip as shown in the video. Then add some surfactant into the side of the container and observe the reaction taking place. Here is a closer look at what happens to the paper clip when surfactant is added to the water. Surface tension is caused by hydrogen bonds between each water molecules. These hydrogen bonds create cohesive forces which pulls each water molecules towards one another. The water molecule on the surface does not have neighboring water molecules above it, therefore the cohesive forces will not be shared equally in all directions. This results in a net force, allowing it to resist external force caused by objects which have a higher density than it. Addition of surfactant lowered the surface tension region in the center, causing food dye to flow from the center to the edges of the container, as these regions will exert a greater pull due to a higher surface tension.
One of the properties of water, known as surface tension, occurs within our lungs. The inside of our lungs are coated with a liquid lining comprised of 2 layers, known as the serous and mucus layer, where the mucus layer is above the serous layer. In order for our lungs to function properly, there needs to be a specific pressure difference between the inside and the outside of the alveoli. The high surface tension in our lungs obstructs this pressure difference, which is essential for our alveoli to expand and fill with air. Fortunately, the alveoli are made up of epithelial cuboidal cells, known as either alveolar type 2 cells or pneumocytes, located within our alveolar wall synthesizes pulmonary surfactants, which are then secreted into the air-liquid interface to significantly reduce the surface tension in the alveolar sac, or alveolus, thus creating the essential pressure difference in order for respiration to occur correctly in our lungs. This process of manufacturing and secretion of surfactants allows our lungs to be more compliant.
Thank you so much for watching our video.
And we hope you enjoyed it as much as we did.
Thank you again, and we hope to see you next time.